Hello. You remember in the last class we were discussing about the non-Newtonian fluid, right? And we had also developed velocity at any instance, the expression for the velocity that we had done, right? Now, if we go to that, this we had developed that velocity was at any instance v was delta p, right, by 2 k L, right, to the power 1 by n, right, to the and r to the power 1 by n plus 1 divided by 1 by n plus 1 within that limit of r to r, and this was n by n plus 1, right, into delta p by 2 k L to the power 1 by n and r to the power n plus 1 by n into 1 minus r by r to the power n plus 1 by n, right. This we had developed in the previous class, right. So, this is the instantaneous velocity. Now, I would like to go back to a little as recapitulation, because I got some information from the student side that if I explain a little more about the momentum, relation between momentum and the shear stress, right. So, a relation between momentum and shear stress, if we look at the definition, momentum we said is equals to rho v, right, rho into v, right. So, rho v, if this is the momentum, then this is rho is kg per meter cube into meter per second, right. So, this is called momentum, momentum, momentum per unit volume, right, or can also write as momentum, right, per meter cube, right, where this is kg meter per second per meter cube, right. So, this is momentum. Now, this also be a recapitulation that shear stress, when we write with the two planes, right, two dimensions, there are two coordinates, that is tau yz or tau xr or rather r theta, right, whatever there, right, depending on the coordinate system you are employing. Now, this tau yz, this we can interpret as this is equals to flux of z directed momentum acting on the y direction, right, z directed momentum acting on the y direction, right. This can also be written as the rate of flow of momentum per unit area, right. This can also be written as this, and the unit of momentum, obviously we have said that unit of momentum is kg meter per second, yes, kg meter per second, and shear stress, then this can be written as tau yz is equal to kg meter per second per meter square into second, right. The moment rate is there, that is per unit time, right. Any rate is per unit time, and per unit area we have said. So, this is per unit area and this is the momentum. So, this we can say momentum per meter square per second, right. That is why this is called momentum flux, right. So, any flux is that thing per unit area per unit time, that is the flux of that thing. If it is momentum, momentum, if it is heat, heat, if it is mass, mass, whatever it be, that flux of that thing means per unit time per unit area is the flux of that thing, right. So, this is true whether it is for momentum or for heat or for mass. So, depending on what variable you are taking, that will be the flux of that thing, that per unit time per unit area. So, and rate means anything per unit time is the rate, right. So, how you are, at what rate you are moving is as it is being said in terms of velocity, that is meter per second. So, this is the rate at which you are moving, right. Your velocity is like that. Similarly, any other thing per unit time is the rate of that thing, right. So, this we can say that this gives us an amount. This is what is the amount of momentum transferred per unit time per unit area, right. So, this we have done a recapitulation, right. Whenever this comes into, so please bring to our notice, we will definitely bring back again and we will try to explain as much as we can. Now, from this expression that V is which we developed, V is equals to delta n by n plus 1 delta p by 2 k L to the power 1 by n r to the power n plus 1 by n into 1 minus r by r to the power n plus 1 by n. So, this tells that the velocity profile is something like parabolic, right. So, velocity profile is something like parabolic. So, that parabolic in nature depending on in which direction you are taking. So, it can be like this, it can be like this. So, we need to know, that means it has a maximum, right. So, if we again draw that pipe, this is the pipe, this is the diameter, this is the axis, right. Then the velocity profile looks like this, right. That means it is 0 at the surface and maximum at the center, right. So, if this is r, right, if this is R, then, and if this is capital R, right. So, the maximum velocity we can write this to be V max, right, and that is true when R is equals to 0. So, in this expression, if we put R is equals to 0, then V becomes V max, and then we can write n by n plus 1, right, into delta p by 2 k L. This remains unchanged, 1 by n, right, and since this is 0, right, so this is 1. So, that means into r to the power n plus 1 by n. So, the maximum velocity is this, right. So, V is equals to V max, that means V is equals to V max at r is equals to 0, right. So, this we know and we have seen earlier in pipe flow also. Now, here also we can see, we had told you that limiting condition, right. This is the non Newtonian, right, and now if we put n is equals to 1, that is if it is Newtonian, then it becomes 1 by 1 plus 1. Okay, let me write in another page. So, V max equal to n by n plus 1, right, into delta p by 2 k L, right, to the power 1 by n r to the power n plus 1 by n, right. This is for any power law fluid, or conventionally we call non Newtonian for any non Newtonian fluid, right. So, if this be true, then we said that for any limiting condition, if this holds good, right. So, what can be the limiting condition? Limiting condition is n is equals to 1, that is Newtonian fluid. That is for Newtonian fluid. So, V max we can write for Newtonian fluid, here we write Newtonian, that is equals to n is 1. So, 1 by 2, right, delta p by 2 k is, okay, here n is equals to 1 and k is equals to mu, right. So, delta p by 2 mu L, right, 1 by n is equals to 1 r to the power n plus 1 by n, that is n is 1 r square, right. So, this is nothing but delta p by 4 mu L r square. So, that is corresponding to the Newtonian fluid flowing through a pipe. This we have done earlier. So, this is R and this is capital R, right, and flow is taking place in this direction, and velocity profile is like this, and the maximum velocity is this. This we have done earlier, and you can check that the one which we have said, this for power law fluid, that is fluid following the power law, where n can be any value, which earlier we said n is what for what kind of fluid, and generally it is called non Newtonian fluids, right. And typically it is Newtonian when n becomes 1 and k becomes mu. So, under that situation, this turns out to be the expression developed for Newtonian fluid flowing through the pipe, right. That means, the development or the proceedings which we have done is correct and it is following the limiting condition, right. Very good. Now, we look into when we have sent velocity at any instance, at any point, that is v, right, instantaneous velocity. So, we have also seen the maximum velocity that is at r is equals to 0, right. Now, next is what is the average velocity, right. What is the average velocity, right. Now, average, if you remember, we had said that for average velocity you need 1 by area, that is pi r square, right, and 0 to r. So, we had shown earlier in many times, a number of times, that how area and how the velocity, they are both together is coming into picture, right. So, here we are taking directly 1 by pi r square, that is the area. So, 0 to r, and this is v 2 pi r dr, right. So, that is there. So, this means we can write this 2 pi r, right, dr. So, 2 comes out, pi goes out. So, it is 2 by r square, right, 2 by r square, we can write 0 to r, right, v r dr. Okay. Now, this v, if we substitute with r, okay, v r dr, right. Now, substituting the values of v, we can write 0 to r, the value of v was this, value of v was this, right. So, if we substitute this value of v, that it is n by n plus 1, right, delta p by 2 k L to the power 1 by n r to the power n plus 1 by n, right, times it was 1 minus r by r to the power n plus 1 by n, right, times this is v, already 2 we have taken out, pi is out, into r dr, right. So, this on simplification we or on integration, okay, before that again we simplify a little, 0 to 2 by r square, this is n by n plus 1, because that is also not within the integration, or we can call to be constant 2 k L to the power 1 by n and r to the power n plus 1 by n, and remaining is 0 to r, right. This is r dr minus 0 to r r into r into r to the power n plus 1 by n, that is 1. So, 2 n plus 1. So, r to the power 2n plus 1 by n divided by r to the power n plus 1 by n dr, right. So, this on simplification we can write that this is equal to, so this r if it goes with, okay, this is beyond. So, if this r square goes with this, so it is r to the power minus 2, right. So, minus 2n, right. So, that is 1 minus n, right, by n, r to the power 1 minus n by n. So, we can write V average is equals to 2 by r square, or okay, 2 into n by n plus 1, right, delta p by 2 k L to the power 1 by n, and this r becomes 1 minus n by n, because this again this r square goes in up as r to the power minus 2. So, n plus 1 by n minus 2. So, n plus 1 by n minus 2, this is equals to n plus 1 minus 2n divided by n is equal to 1 minus n by n, right. So, this is r to the power 1 minus n by n, right, and here we write this is under bracket, okay, that should have been. So, it is r dr with a boundary of 0 to r. So, r square by 2, that means r square by 2, right, minus this is again r, that is 1 by r to the power n plus 1 by n, this remains common, and we write at r is equals to r, this is r to the power 2n plus 1 by n, again 2n plus 1 by n plus 1 divided by 2n plus 1 by n, that means this becomes equals to 2n plus n. So, 3n plus 1 divided by n divided by 3n plus 1 by n, right. So, we can write this to be equals to r to the power 3n plus 1 by n, right, divided by r to the power n plus 1, oh, this we have already taken out, right, okay, r to the power this we have taken out. So, 3n plus 1 by n, right. So, if we now rewrite, this is equals to 2 into n by n plus 1 delta p by 2 k L to the power 1 by n r to the power 1 minus n by n, and let us rewrite r square by 2 minus 1 by r to or okay, we write r to the power 3n plus 1 by n divided by 3n plus 1 by n, right, 3n plus 1 by n into r to the power n plus 1 by n, right. So, on simplification we can write this term remains same a into r. So, this we can write. So, r to the power 3n plus 1 by n minus n plus 1 by n, this becomes n, and 3n plus 1 minus n minus 1. So, this becomes 2n by n, right, 2n by n. So, this 1 goes out, this 1 2n, right. So, 2n, that is r. So, here it is r square by 2 minus, this is r to the power 2n by n. So, that is r square again by 3n plus 1 by n, right. So, if we again simplify, this is a into r square by 2, right. So, this is 2 into 3n plus 1 by n, right. So, r square into n 3n plus 1 by n, this minus this is 2 r square, right. This is equals to a times, right, on the denominator 2 3n plus 1 divided by n. On the numerator, if we take r square as common, then we can write r square into a, r square we take common, then it becomes 3n plus 1 by n minus 2, right. So, we can write a r square into, this becomes 2n, 3n minus 2n, that is n plus 1 by n whole divided by 2 into 3n plus 1 divided by n. So, this n, that n goes out. So, ultimately it comes equal to a r square into n plus 1 by 2 into 3n plus 1, right. Now, if we substitute the value of a which we were doing, it is 2 into n by n plus 1 into delta p by 2 k l to the power 1 by n r to the power 1 minus n by n, right, into r square, right, a square into n plus 1 by 2 into 3n plus 1. So, this is that. So, which we can write, this 2 goes out, right. This n plus 1, this n plus 1 goes out. So, n by 3n plus 1, this becomes that. This is delta p by 2 k l to the power 1 by n and r to the power 1 minus n by n plus 2. So, that means this is equal to n by 3n plus 1 into delta p by 2 k l to the power 1 by n into r to the power n. This is 2n minus n, that is n plus 1 by n, right. So, if you see that the final average velocity is like that. Okay. Now, time is out. Thank you.